Hello, in this video I want to show the current specifications and the current, at least what I know about the Zeta guard, about the PoP service, about e-prescriptions. So basically what I want to explain, so if you're a patient and you are in a pharmacy, so here you're in a pharmacy, and you hand over your EGK, the pharmacist, and he basically puts it in a card terminal. In this particular case, let's say it's a PSCS card reader. It's not an eHealth card terminal, it's a PSCS card reader. So how this will get processed. Okay, the goal is get e-prescriptions. So what we have is we have an AVS, and in the new world, this AVS implements two things. It implements a Zeta client and it implements a PoP client, and then in the end it will also need an e-prescription client. Okay, so how does this now all start? So in the end, in the e-prescription service, this service has the e-prescriptions. And the typical URL of this service, it's erp.central.erp-possibilities.ti. This is the URL, and I will just copy it and add it here. And now, what does the AVS has to do? So, the new domain services, die neuen Fachdienste, so particularly the PoP server or PoP service, they are governed by a Zeta guard. And behind the Zeta guard, there is the PoP service. And what you will do, so there's one thing, and I won't go into detail about that because it's not 100% sure how it works yet. The Zeta client can register as a device at the Zeta guard. I don't know if this will be required for an AVS for the e-prescriptions, but I won't go into detail. So what I will do is I will explain when you have this Zeta guard and you want to request the PoP service, the first thing what you have to do is you have to create an SMCB DPoP token. And this SMCB DPoP token is created locally. And what you typically do is you have a connector, and there is a card terminal, eHealth card terminal. And this eHealth card terminal has an SMCB. And this SMCB, it has a function external authenticate. And this is what you will use to sign the DPoP token. I'm not 100% sure if it's possible to also put the SMCB into a PSCS card reader. So I would just wait for it if this will be allowed. But if you're using a TI gateway with a virtualized SMCB, then you definitely have to use a connector. So in this particular case, this function here, it's the SOAP function, external authenticate. External authenticate. And there is already an implementation for this. I will show this for you. So if you go into Zeta SDK, so this is open source, it's developed by EY Consulting. There is the Zeta client in Java. And if you look into main, you will see that there is an SMCB token provider. And typically, if it's a normal connector one, the SMCB token provider is used, and this is Kotlin code. This is a little bit mean, so if you click on the GitHub page, you won't find it. So what you have to do is you have to use this search, and then you will find the Kotlin code here. And in this Kotlin code, you can basically see that it uses a connector, then it uses some other nice things like using a TPM and getting some registration numbers, so making really sure that the client is in a certain state. But this is optional, so you don't have to do this, but you can. The important thing is this sign SMCB token here. So what happens? It's generating some values, and then it's signing these values, and this is basically the signed proof that an organization is really an organization, and this will be handed over to the Zeta guard. At the moment, I'm not 100% sure if this is a normal header, but typically this is a header. So let's check this. Let's search here for DPoP token. Yeah. So yeah, it says there is this DPoP token. We'll just check how it is. So it has to be in the authorization header. So it's based on RFC 9449 here. And let me just check what the header name is. DPoP HTTP header. Okay. Oh, okay. So the header is DPoP. So this is how the header will look like. And also for everybody who is interested to look into such things, there's jw2.io, and you can just paste it here. And actually, this one is not a valid token because it has new lines in it, and I'm not going to remove these new lines. But let's just go. So we have now this SMCB DPoP token, and this will be part of a typical Zeta guard client request. And in this particular case, this will be upgraded to a WebSocket. So if you're doing this here, the Zeta guard from the PoP service is configured in the way that you are allowed to create the WebSocket. And then if you have this WebSocket, actually I can show you, there is the API of the PoP service. So there is API PoP. And this API PoP, it contains an open API specification. Let me just check that this is the most important one. So it's, I think this here is the most recent one. So this describes endpoints to get a PoP token for a normal Leistungserbringer, so for a doctor or pharmacy or so on. And yeah, so this is the URL. So this is the URL that you will connect to, and it does not directly go to the PoP service, but it goes through the Zeta guard to the PoP service. So basically here is in this PoP service, there is this URL, and this is the URL that you have to communicate to. So you initialize a WebSocket with this nice DPoP token here, and then you are allowed to talk to this token generation. So then what's basically happening, if this is done, the PoP client can basically do its magic. So what the how this protocol works is that there is a WebSocket exchange. And I have to look into the spec. So there's typically the standard scenario. So there are different kinds of scenarios and there are different kinds of connector messages. And there are also different ways you can have something in the in a PCSC reader, or you can have something in the normal reader. And there is already a client implementation from the Gematik. It's here, and let's just check how the client works. So this client does not have an Zeta guard integrated, which means that this system is not creating this DPoP token. So this is something what you have to add to the system that it works. Yeah. So and then basically this token is this get token system is called, and so this the client itself, it's a Spring Boot application. You start it and you enter your URL, and then based on the URL, it will use a normal card reader, or it will use a connector, or it will use something else, maybe NFC card. And let's go through this contact connector. So this is this contact connector. There's the communication service. So there's the connector communication service, and let's just try to find implementation of this connector service. So this is Java. I should be able to just click here. Yeah, and then it shows me the real connector implementation. So this is the real connector implementation. This is what's happening, and basically it receives a message, and then it runs this whole message against the connector, and the whole message basically contains mainly APDUs. So what's happening here is, so there's this WebSocket. And this WebSocket, it contains a scenario message. So, and this scenario typically contains a lot of signed APDUs. So let me just check this here in the specification. So where it is, there's this, where's the scenario? Connector scenario message. So this is the scenario message. And here it contains these steps. So there is this message, and then there are the different kinds of steps, and then there are the expected status words. So basically there is step 1, and this would be something like, this is a select file, this is a root file, so 00A4, this is select root file. And also this whole thing is signed, which basically makes it possible to make sure that sometimes only a connector is executing these commands, and the connector can also backsign it, and then it is really sure that this whole thing was executed by a connector. Yeah. So actually, there is a security thing. You can get the smart card out of the connector, and then you can even do this outside the connector. But yeah, we won't talk about this. There are all these steps. So this is basically what this PoP client is doing. This PoP client sends this message, or it receives this message. So this is here. This message is created by the server. And then after executing all these APDUs, the most important thing, so this scenario message, it contains an internal authenticate step. So let me just add this here. So in one of the steps, I don't know in which one, but in one step, it will have an internal authenticate. So there's an internal authenticate APDU. And this internal authenticate RPDU, this is the only real output that's important. So, and now let's check. There is the scenario response message. So this is a scenario response message. And this also contains steps with the outputs. So basically this goes in the other direction. So this PoP client writes this scenario message, and then this scenario message goes back into this WebSocket. So, and then here it contains response to all the steps. So response is typically, if you have an APDU, then it's the normal value, the payload, and then afterwards you have a 4-digit code. Typically it's 9,000. So 9,000 means it's successful. So there is a video response and video code. Typically 9,000. And also these scenario messages, they contain the expected codes, and if the expected code is not given back, then the PoP client will create an error in the ABS. So, and this in this example will be 3 times. So typically the important things that you will need is one, you need the certificate from the EGK, and you will need the internal authenticate. And also one thing, what you will typically run is an MSE, so managed security environment. This managed security environment will select the correct algorithm that you will need for running the internal authenticate. So 3, and then this is typically, if this is for the internal authenticate, this is a signed challenge. And this goes back to this token service, and then if this all worked, you should get back a PoP token, and this is here in the token message. So this is basically the first one. This is the second one. I will just create numbers. So first scenario message, then this is scenario response message, and then in the end, the third is the token message. And the token message goes again from this service here to the PoP client. And this token message, it really contains the PoP token. And now you have this PoP token in your ABS. I think typically it's valid for 30 minutes. I'm not 100% sure about this. So now this PoP token goes into the e-prescription client, and the e-prescription client also needs an ID token, or still needs an ID token. So technically this is not really necessary because the PoP token already contains cryptographically secured SMCB telematic ID, but maybe for backwards reasons this is still required, and this comes from the IDP. I'm not going to explain anything how this works with this IDP. This is quite complex thing. So getting this ID token with the IDP is not easy. But I won't go into detail how this works because this is already done, and everybody who is in the field knows how to do this. Yeah. Then you have the e-prescription client, and then the last thing what you have to do is you're sending an HTTP request to the task, so it's slash task. You also have to build a file and maybe have a pool, but this is not really the important thing. And this HTTP request, it has two headers. It has the authorization header, and this contains a BIRA token. And the BIRA token contains the ID token. So this one here. So is it a bigger? And it will also have the PoP token. And the PoP token, it is delivered as the header XPoP token. So, and this is described here. So here, there's the XPoP token, and this one goes to the task, and the authorization will be done by an ID token, and the PoP token will be done by the PoP token. So technically, so and this so when you have this e-prescription client, you send these nice requests, and if this was okay, then the prescription service will return the e-prescription for this particular user. Yeah. So if this is easier than before, I leave it to you about the judgment. But this is the zero trust architecture and the PoP architecture, how it's currently imagined to work with the e-prescription service. And you have to implement this little guy here. You have to implement this little guy here. And this PoP service is at the moment not available yet. So you can use a sample implementation, but the sample implementation does not contain this Zeta guard yet. But you are already able to build all this mock stuff on your own. But if you need help, I'm Manuel Blechschmidt. I'm the CEO of the Service Health RX GmbH, and feel free to contact us. We can help you with these parts. We are experts in these fields, and feel free to contact us. Thanks a lot, and talk to you soon. Bye bye.